Let me show you how to be a good PreliZ.
Today, I'm excited to host again the great Osvaldo Martin. Osvaldo collaborates with numerous open source projects, including ArviZ, PyMC, Bambi, PyMC-BART, and PreliZ, helping shape the tools that make Bayesian methods accessible and powerful. He's also an educator, teaching Bayesian statistics at UNSAM in Argentina, and a problem solver for businesses at PyMC Labs. In this episode, Osvaldo shares his insights on Bayesian additive regression trees, or BARTs, explaining their versatility as non-parametric models that are quick to use and effective for variable importance analysis. Osvaldo also introduces PreliZ, a package aimed at improving prior elicitation in Bayesian modeling, and explains how it enhances the Bayesian workflow, particularly in education. From interactive learning tools to future developments in PyMC-BART and ArviZ, Osvaldo highlights the importance of making Bayesian methods more intuitive and accessible for both students and practitioners. This is always a pleasure to have Osvaldo on the show because he does so many things and is a dear friend, and you will also hear from a special surprise guest during the episode, but I am not gonna spoil you the surprise. This is Learning Bayesian Statistics, episode 123, recorded October 17, 2024.
Let me show you how to be a good PreliZ and change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations. What's a Bayesian? It's someone who cares about evidence.
Welcome to Learning Bayesian Statistics, a podcast about Bayesian inference, the methods, the projects, and the people who make it possible. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country. For any info about the show, learnbayesstats.com is the place to be. Show notes, becoming a corporate sponsor, unlocking Bayesian merch, supporting the show on Patreon, everything is in there. That's learnbayesstats.com. If you're interested in one-on-one mentorship, online courses, or statistical consulting, feel free to reach out and book a call at topmate.io/Alex_Andorra. See you around, folks, and best Bayesian wishes to you all. And if today's discussion sparked ideas for your business, well, our team at PyMC Labs can help bring them to life. Check us out at pymc-labs.com.
Hello, my dear Bayesians! Today, I want to thank Mike Loncarrick and Corey Upshire for joining our Patreon in the full posterity or higher. Mike and Corey, thank you so much for your support. This truly makes the show possible. You know, I pay for editing with your contributions, and I make sure you like what you're hearing and seeing, and I can improve the show and keep investing in it and the quality of it. So thank you so much, and I can't wait to talk all stuff Bayes in the Slack channel with you. See you there, guys. I hope you will enjoy your merch, and now on to the show.
Osvaldo Martín, bienvenido de vuelta a Learning Bayesian Statistics.
Muchas gracias. Encantado de estar acá.
Yeah, thank you so much for taking the time. I'm really happy to have you back on the show, third time for you, which is, I think, a record that you hold now with Andrew Gelman. So,
Wow.
it's quite cool.
Okay.
Last time you were on the show when...
No, do you have t-shirts or some gift for us?
Yes, you're gonna get a bottle of wine, but when it's your 10th appearance, so it's like, sounds like I'm, inventing the rules, but no, I'm not. So yeah, last time you were here was for episode 58, March 21st, 2022, and you came to talk with Ravin Kumar and Junbang Lau about your new book at the time, Bayesian Modeling and Computation in Python.
Mm-hmm.
I guess we'll talk a bit about that again today. We'll reference it at least, because that's a really good book, and I think it's still quite useful. And of course, the very first time you were here was the very first
Learn Base Stats episode 1, when we talked about lots of things, and your background in open source, in Bayes, in bioinformatics. So yeah, lots of things happened in the meantime. So I thought it would be good to have you back on the show, because you always do so many things, Osvaldo. So for the listeners, maybe tell us, what you're doing nowadays and what's new, basically, in your professional life since you were last on the show.
Okay, let's try, because I'm like in a transition time, so it's not super easy to set what I'm doing at the moment. Well, the last time I was here, I worked for PreliZ, the National Scientific and Technical Council. I'm not to work there anymore, so I resigned. But I'm still teaching at the university. It's Universidad Nacional de San Martín. It's a university in Buenos Aires. They have a data science program, so I'm teaching there Bayesian statistics. And the good thing is not the first course in Bayesian statistics, it's actually the second course. That's super weird for me, and probably for many people, that you are the second person talking about Bayesian statistics to students. Sounds like weird, but I am. So it's very interesting that you mentioned something and say, yeah, we already saw that. That's a new experience to me. I have been also doing some consulting for PyMC Labs, doing some educational material for intuitive Bayes. Probably we're going to talk about that. And of course, I keep doing work for open source. That is actually my main motivation to wake up every day. At least work-wise. It's my main motivation.
I was going to say, I'm sure Romina, Avril, and Bruno are going to be happy to hear that.
Yeah. So yeah, basically that's what I'm doing now.
Yeah, so quite a lot of things, as listener might have understood. We'll try to touch about a lot of those topics. One I think that is going to be very interesting to start with is BART, so Bayesian Additive Regression trees, because that's one of the things you've developed quite a lot between the publishing of the book in 2022 and now, because you've actually spearheaded basically a sub-package from PyMC called PyMC-BART to especially do Bayesian additive regression trees with PyMC. Maybe, what do you think? Should we? Yeah, let's define very quickly what BART models are and why you split up PyMC-BART from the main package PyMC.
Okay. Bayesian additive regression trees, BART, is a non-parametric model. It's a Bayesian model. And the main idea is that you are trying to approximate functions by adding trees. The number of trees is something that you have to decide. Usually people use something like 15, 100, 200 trees. That's one important thing is that those many trees, that's a single point, is a single function, and then you're going to have like a distribution, because you're Bayesian, you are going to have a distribution of some of trees, and that's what is PyMC-BART is computing. The main motivation to have PyMC-BART was not only bringing BART models to PyMC, it was also trying to make really work for probabilistic programming languages. If you check the literature about BART, you're going to see that most of the time people discuss BART as standalone models. So you have like a package that can fit one or two variation of a BART model, and then there is a new paper describing a new variation, and sometimes there is a package for that, and so on and so on. So it's like very this thing that you have one model and then you have inference method tailored to that model. So what I wanted to do with PyMC-BART was having something that is completely independent, or at least try to do that. So essentially that you can mix BART models with whatever you want. So the main thing is probably that you want to switch between likelihoods. So if you want, you can have a normal likelihood that is typical thing, but you can have a gamma likelihood or whatever, negative binomial, whatever you need, and you can mix BART models with linear models or maybe Gaussian processes or whatever you want in a single model. So that's the main motivation to create PyMC-BART. And one of the reasons to split it was probably just a matter of organization in a sense, because it's not only, I mean, essentially it's super easy to have BART models into PyMC because you already use a lot of the technology, a lot of the tools that are already implemented in PyMC. So the things that you need to add as a technical level is you need a distribution or something that like works as a distribution. There's a BART distribution that behaves similar to gamma, normal, whatever, and then a sampler. So it's some way to get samples from a BART model. And the reason you need a specific method to get samples is because trees are discrete or kind of a weird kind of discrete thing. So you cannot use a Hamiltonian Monte Carlo or method like that. So you need a special method, and sampling from trees can be tricky. But essentially, once you have those two elements, you can add it to PyMC and everything should work. But then you say, okay, it's not enough. Maybe you want some functionality, extra functionality, like plot for diagnostics and plot for variable importance. That's something that you can do with BART models. You can not only fit a model and obtain a posterior and make predictions, you can also try to analyze which of the variables in your model are more important than the others, which one are the relevance, that kind of thing. So that requires extra functionality. So it makes more sense to have that functionality. That kind of functionality is like too specific to have in a package that is so general, like PyMC. So it makes sense to split it. And at that time we have actually BART was first in PyMC. I think for the book it was inside PyMC. Then we move it to PyMC experimental. That is this package that has methods that are not necessarily experimental in the sense that they don't work, experimental in the sense there are extra functionality. And then we decided, okay, maybe we need a specific package. So that's the current status. We have a specific package for that.
And so, to make sure listeners understand well, when would you recommend using a BART model?
A BART model? I would recommend a BART model when you are super lazy. I think that's the best. That's the best way to use a BART model. And the reason is that there is plenty of literature showing that you get good results with BART models without putting too much thought on what you're doing. So in some sense, they are competitive against things like Gaussian processes or splines. Usually for those, you need to think better. For instance, for a spline, you need to think, okay, where I'm going to put the nodes or things like that. For Gaussian processes, there are a lot of things that you can actually tweak. And for BART, it's like usually there's not too many options. So you just define the likelihood, the prior, or as I say, if you have something else like a linear model or something like that, you put together and you get something that is usually super reasonable. That doesn't mean that you cannot get better. Usually if you put a little bit of more thought, you can do that. And for that case, Gaussian processes are excellent because you can mix and match different kernels and that kind of thing, and that gives you more interpretability and more custom model. But I think BART excels when you want something relatively quick, or you don't have a lot of domain knowledge to do a more tailored model. So that's probably a very good case. And I think another one is when you have you want to get information about variables, important variables. That's also something that there are quite a few examples in the literature when people, the main goal of analysis is to understand which variables are more important. So maybe it's not that you want predictions, you want to know, you understand which variables are the most relevant for your problem. And for that case is very good. And the thing is that we have a particular method in PyMC-BART that is, I have not seen that method elsewhere, that allows to interpret variable importance a little bit easier, because essentially, to explain, the method to understand variable importance is that essentially you count how many times you fit a lot of trees. The trees can have one or two, they're usually very shallow, so they usually incorporate 1, 2, 3, probably no more than that, covariates. So essentially then you count how many times your first covariate goes into the trees, how many times the second, the third, etc. And then you say you plot that information relative frequency, and that's it. That's the importance. But that's not super easy to understand how to interpret that, because essentially you get relative frequencies, so you don't know where you have to cut and say this is important, this is not important. And there are some heuristic out there that try to help you with that. It's not that people have not thought about that, but I think we have something that is much more easier in PyMC-BART. That essentially what we do is we generate predictions from submodels. So essentially we generate predictions for the whole model, and then what we do is prune the trees to generate submodels. So a model with, let's say we have a model with 10 covariates. That's our reference model. So we generate prediction from that. Then we simulate that we only have 9 covariates and generate predictions from that. And so forth until we have only 1 covariate. Essentially we plot that information. So you get a curve like saturates at some point. And that's much more easy to interpret, because essentially it's easy to spot the smallest submodel that allows you to generate the closest predictions to the reference model. And actually that's an idea that we take from other places, that the same thing that, for instance, ProcPred in R does, or CoolPred in Python. This different the way that we generate the submodels and we compute the predictions, but the idea of comparing to the reference model, that's the key point, I think. So you generate predictions to a reference model and then compare your prediction of your submodels to that reference. So that's something that you can, and that's super cheap to do, because you don't need to refit you only fit the BART model once. And for the rest, we try to kind of approximate the submodel. So that's super cheap to do it once you fit your BART model.
Nice. Yeah, thanks for that great summary. Definitely recommend people to check out the chapter of your book about bots. I'll put the link in the show notes, because you guys and your editor have been kind enough to have the online version free on the website. So I put a link to that. And of course, if you are interested in the whole book, which I definitely recommend, I recommend buying a hard copy, because I often find myself, referencing it where I forget something about BART, or the time series chapter is also very interesting. I really love it. I always forget, the nuances of time series models, because it's a lot of things to tweak and remember. And the BART chapter also is really, really well written and explained and very clear. So I definitely recommend that.
Yeah, we now also have a paper archive that it's kind of mix of writing style that is close to a typical scientific paper, but also some elements more tailored to practitioners. So we try to provide some recommendations on, for instance, how to choose the number of trees, and we explain what I just explained about variable selection and how to do it, and that kind of thing. So that's also something that I think is easy to read.
Yeah. You're talking about the paragraph, the chapter of the book, or is that something else?
No, I mean our archive paper. It's a paper on archive.
Yeah. Okay. I see. Oh yeah, so we definitely need to link to that too. I wasn't aware you had that. So yeah, definitely we want that in the show notes. So yeah, feel free to add that to the document I'll share with you.
And also one of the reasons I mentioned this archive paper is that, as you say, when we published the book, I think we have like one of the earliest version of BART model in PyMC. So we have changed. I mean, the theory, of course, is the same, and the examples still work, and we have actually updated the examples in the book. So if you go to the repository, you're going to see that the examples updated in one of the newest version of PyMC. So it's still worth reading that. But we introduced a few changes in the API of BART. We try to make it a little bit more easier to use, more flexible. And actually now there is Gabriel Stadschulte. He's a core developer of Bambi, and he's doing a superb job on speeding up PyMC-BART. He's essentially he's rewriting PyMC-BART in Rust.
Okay.
And we follow some of the advice and experience from NotPy that you already have discussed in the show. And we are seeing a speed up of like 10 times or so. So
nice.
we are super happy. I think that's going to be ready by the end of this year, probably.
Okay.
December, maybe.
So maybe that will be out by the time we publish this episode.
Yeah.
That'd be great. What should I link to? Just the GitHub repo of PyMC-BART?
Mm-hmm.
Okay. Yeah.
Yeah. Now it's living in a separate repo, but it's going to be the same thing.
Yeah, it's
together.
Going to be there.
So for users should not notice anything except that the models are going to run much faster.
Yeah.
But it should be super easy for them to just run PyMC-BART.
Nice. Well, awesome. That is really cool. Yeah, maybe we should get Gabriel on the show to talk about that, and also some Bambi stuff, because I know he does a lot of things on the Bambi side. He's doing tremendous work for Bambi. I didn't know he was doing that for PyMC-BART, but really happy to hear that. And he's also a patron of the show, so thank you.
Okay.
Triple thank you, Gabriel.
Yeah, one of the things that we have in PyMC-BART is that we have this plot dependence plot. Plot dependence. Yeah, I don't know.
Yeah, partial dependent
plot. That's the other P.
Yeah,
I was missing one P. Yeah, partial dependent plots. That's a cool way to try to add a little bit of interpretability to models. And I mentioned this because Gabriel has worked on something similar in Bambi. It's specifically tailored for linear models or models that are available in Bambi. That this is interpret model. They compute things that are kind of similar. And the point is that how can I try to better understand my model? And the answer is make predictions from the model and make plots. And usually that's easier than trying to understand parameters in linear models. And of course, for non-parametric models like BART, the parameters that you fit doesn't make too much sense because they are branch of the trees or things like that.
Yeah. I mean, completely agree with that. My experience personally also working on models is, really first making in-sample predictions, making plots, and then making out-of-sample predictions and making plots of them. spend most of my time writing code so that the plots look good and I can understand them, much more than the actual model code. I don't know about you, but yeah, it's like most of the work is actually handling the shape issues when you're plotting, and then handling the shape issues when you're doing out of sample predictions.
Mm-hmm. Yeah, and that's one of the things Bambi tries to simplify it a lot. No, because it's interpret model that has some summary, numerical summaries, and also plots. And usually the plots are super useful just out of the box.
Oh yeah. I mean, I lose Bambi like all the time, especially when I'm developing a model. Then when I know the final structure of the model, and I know when I add some more complicated structure to it, especially time series, like structural time series, for instance, or Gaussian random walk, they don't exist in Bambi, at least yet. So then you have to go back to PyMC and write the full model. But I find that to do the iterative process of just, trying a bunch of stuff, it's really awesome to have Bambi, because then it's really easy to iterate on the covariates. And then you have those plots, as you were saying, which just go work out of the box. And the best is really the out of sample predictions, where you don't have to handle any of the shape issues. And that's absolutely fantastic. I don't think you can do BART with Bambi yet, right?
No, but that's one idea. That's something that we would like to have, because I think it fits very well into the Bambi ethos, because it's like, as I say, many times you want to use BART as something like quick to explore a model, coming of like a baseline. Sometimes it's enough, because people actually use BART as their final model. There's a lot of papers using just BART. But even if you're not entirely happy with the result, then you can iterate and create something much flexible or more tailored. And I think that fits quite well into Bambi's.
Yeah, definitely. I mean, Gabriel, you're the person indicated to do that. I mean, like working on BART, working on Bambi. I'm almost disappointed you haven't done that yet, Gabriel. What are you doing? No, completely agree. That'd be fantastic. Actually, I'd be super happy to give a hand on that, because I think that'd be super fun. Also adding time series and state space methods and so on, that would be fantastic. We're gonna have Jesse Grabowski on the show in a few weeks, and he's been spearheading a whole submodule in PyMC experimental doing state space methods. And I think that'd be great. If Bambi could plug into that state space submodule, and then boom, you have state space method in Bambi. That'd be awesome. So since you are talking about Bambi and BART, I thought, you know what, we should bring in someone who actually knows the nitty-gritty of Bambi. What do you say?
You already have Thomas.
Yeah, but I mean now, during the show, during the conversation. Yeah.
Okay.
Because
sure.
like because last time, I don't know if you probably know that the first episode you recorded with me, Tommy Capretto. So he was on the show, folks, a few episodes ago. I'll put the show in the show notes. But yeah, last time you were on the show for the first episode, Tommy was actually in the office, like just adjacent to you. Yeah. And just eavesdropping. So, I think we should just invite him. Well, what do you say? Well, look at that. No, he didn't even ask for permission.
Why do you laugh? What's happening here?
Hi, Tommy. Yeah. Thanks.
I'm not at home. I'm in Buenos Aires.
Yeah. So Tommy, now so you don't have to eavesdrop anymore. You can just join the episode, without even asking. So that's awesome. Yeah, but no, kidding aside, thanks for joining, Tony. That's great to have you both here. I think you had a few questions for Osvaldo.
Yeah,
You
yeah.
told me.
So, to be honest, I don't know what to be talking about. I didn't have the chance to be listening this time, but I can imagine some of the topics.
Yeah, we were talking about Bambi, and Osvaldo was saying it was not that good. I was saying, yeah, it's getting better. So yeah.
And
Now
eventually
that
it's going to become usable.
yeah.
Yeah.
So some people find it useful. Uh, I don't know, Osvaldo, if you talked about your teaching activities that you have this semester. Have you talked about that?
No, I briefly mentioned that I'm working on some, but and I briefly mentioned that it's actually the second course in Bayesian statistics, so I'm super surprised that I'm not the first person talking to the students about Bayesian stats or base factors or, I don't know, sampling from a posterior, that kind of thing.
Okay, so since you mentioned that, so this is the second course. Do you already have in mind what would be the third course, or is it so specific that it's more like pick your own adventure and go deep into that?
I don't know. I think there are many options. Probably one course that could be like a third course is something that is more based on solving problems. That could be an option, like more like a workshop that you work on problems and discuss some problems, and students share their findings and the improvement, that kind of thing, so that you can put in practice a lot of ideas of the workflow on diagnostics and going back and forth, that kind of thing, and putting things in context. That was something that I tried to do in this second course, but it's usually kind of difficult when examples are simple. I don't know. I don't have the time to. It's difficult because usually when you teach, things tend to be like very linear.
Yeah.
And when you work on a model, things tend to be non-linear at all. So that difference is something that could be. We could try some work on that. The other option could be, but there are still plenty of topics to discuss, like survival models, or putting more emphasis on not just understanding or this second course is like they already know about linear models, so we briefly talk about them and discuss a few more things about doing linear models using Bayesian statistics. But linear models is something like it's so so vast that you can just have a course to say, okay, we are going to discuss linear models again, more in practice on all this and the things that we were discussing before, like the making predictions for linear models so you can understand linear models and that kind of thing. I don't know. So there are many things that we could do for a third kind of course.
I really like the fact you mentioned that case study based approach. Like, okay, in this semester we're going to work on these 4 problems. I think that approach would be like a very good opportunity to invest time in prior elicitation. I don't know if you talked about prior elicitation before. I know you have been working a lot in PreliZ, which is a great tool that's it's been around for some time, and I see that you are constantly like adding things to it. And I think that we as a community, we are not using it enough. At least myself in my workflow, I end up reinventing many of the things that are already implemented in PreliZ. And yeah, what do you have any analysis about the situation regarding tools for prior elicitation? Because I think it's something it's mentioned a lot, but I know PreliZ, but I don't know many other tools or people advocating for
Sure.
tools for prior elicitation.
Well,
Yeah.
we have,
And I think it's also worthy to introduce PreliZ and to talk about it, Osvaldo, sure, about where it's at, where you'd like to take it, and things like that.
Yeah, sure. Well, the first thing is that we have a paper with many other. I have a paper with as a co-author of the paper with many other people from Aalto University, Helsinki University, and other universities that we discuss prior elicitation. This paper has this kind of thing that, okay, where are we with prior elicitation? What we need to do? What are the approaches, tools out there? And one of the sections is discussing prior elicitation in the framework of the Bayesian workflow. So when do you always want to do prior elicitation? Is something that you always want to do? Is something that you always want to do at the beginning? That kind of thing. And of course, the answer is not. Sometimes you don't just do prior elicitation at the beginning. Sometimes you do it after a while. And sometimes you want to spend a lot of time doing prior elicitation. Sometimes you just want to just default priors, like priors in Bambi or whatever. So there is a section discussing that. There is also a section about prior elicitation software. That's something that is lacking. And actually, PreliZ is an answer to that. In a sense, it's an answer to that paper. If we say there, okay, we don't have good enough tools. We don't have the tools that we have are like very sparse in the sense that they are not in the same place. So it's not easy to discover that you have different tools. And many of these tools are not integrated or not integrate well with probabilistic programming languages. So maybe a tool is just, I don't know, a web page where you can try to do some prior elicitation, but then you get something and you have to manually move numbers into PyMC or PyStan or whatever. So that's one of the goals of PreliZ, trying to answer all these issues. So essentially, I started working on PreliZ when I was working at Aalto University, and we were writing the paper. So yes, it has been a while. And one of the reasons I'm still not super happy with PreliZ, maybe I can mention what we have in PreliZ now and what we don't have. So essentially, PreliZ is a packet for prior elicitation or for distribution elicitation, if you want. Sometimes you want to elicitate likelihoods also, not only priors. It's a sister project with ArviZ. So that's the reason it has a similar logo, it has a similar name, is because it's actually live inside ArviZ Depths repository, ArviZ organization. And the focus, as I say, is distribution elicitation. So one of the things that ArviZ provides is a collection of distribution, like the distribution that you maybe find in PyMC or maybe you find in SciPy. And compared to SciPy, one difference is that the parameterization is a little bit more statistical inclined. Okay, so usually the name of the parameters are the same names that you are going to find in textbooks, that you are going to find in probabilistic programming languages. So that's a thing. And also we support alternative parameterization. So for gamma, you have alpha and beta, but you also have mu and sigma. The same goes for beta distribution, etc. And then what we offer with the distribution is that easy to define a distribution, to plot the distribution. So we have functions to plot it, just to CDF, the PDF, also interactive functions. So you can just call the distribution and move sliders. So you see what happens if I increase this parameters and decrease this other parameter, and how the distribution change. So there are many functionalities at the level of the distribution, and that I think is already something super useful, because as we were saying when you teach statistics, people usually are familiar with distributions like, I don't know, normal, maybe gamma or binomial. And then you mention beta distribution or you mention something else and they say, what? So it's easy to say, who's the distribution? Let's play a little bit. They get familiar with the distribution. So now we are also adding documentation specifically tailored to distribution. So you have a gallery of distribution and you can go there and you're going to see a short description of properties of the distribution, how the distribution is used, that kind of thing. So all these things are super simple in a sense, thanks, but I think they are already useful. And as you say, if you don't have these things, you have to invent yourself. You have to write yourself because you use it in practice. So it's better that someone already do that for you. And then because we have the distribution, we try to work on top of the distribution. So for instance, we have methods that can modify the distribution. We have one method that is called maxn, because maximum entropy. So essentially you can pass, it's a function and you pass distribution, whatever distribution you want. And then you say, okay, I want this distribution, but I want the distribution that is bounded to be between this value and this value. And 90%, 80% of the mass is going to be between those boundaries. And the thing is that if you only do that, for many distributions, you can, in principle, you can have infinite distributions as answers. So we add this extra restriction that they say, okay, I don't want any distribution. I want the maximum entropy distribution. So it's the more spread distribution that satisfies these constraints. And that's what is computing. That again is, I think, simple idea. It's an old idea, but it's something that is useful, very useful in practice to have. And I actually, probably one of the functions that I use most in after the distribution itself is the other function that I use most from PreliZ all the time. And then there is also a little bit more flexibility because you can fit parameter if you want. If you have like a t-student distribution and you say, okay, I want to fix nu at 7, you can fix nu at 7, and then do the rest with maximum entropy, or you can fix whatever parameter you want. I mean, some parameters make sense, some others doesn't make too much sense to fix, but you can do it. Usually it's not going to complain, it's just going to give you the distribution that satisfies the restrictions. And then we also have some functionality. One method that is commonly used in practice is called a roulette method, like roulette, like in casino. And the name of roulette is because you have like I think the analogy is that you have a certain amount of chips that you want to bet, in a sense. So where do you want to place the chips? And of course, you want to place the chips where do you think the distribution has more chance to be, something like that. So that's one way to see it, and that explains the name. But the other thing, if you see this functionality, you're going to see that what you are doing is essentially drawing a histogram. So essentially you have a grid, okay? And you have on this grid, you can activate cells of the grid, and then you get something that looks like an histogram. And then you can pick from a pool of distribution and say, okay, if my distribution looks like this histogram, what distribution fits the best here? And it's essentially you can pass all distribution in PreliZ, or you can select one or two distributions or whatever. It's very flexible. And that's it. And you get a distribution, you can do stuff with that distribution. And that's something that's is very common in prior elicitation literature. If you read literature, you're going to that method appears many times, mention it. There are actual papers or tutorials with protocols about how to use that method if you have like many experts. And that's something that you can do in PreliZ. So for instance, the three of us can go and use that elicitation method. We can then collect our three elicited distributions, and we can put it together in a single distribution, and we can add weights. And we say, okay, Thomas probably is an expert in this field, so I'm going to give more weight, and Alex and we don't know anything, so we have little smaller ways, something like that, and you can do that. So that's also something super useful. The thing that there are some functionality, but I think is missing at this point is elicitation, what is called predictive elicitation. All the things I have been talking about are elicitation at the parameter level. So you have it, you know that you have something like this slope, or you have something like this. I don't know, it's something in your model, and it's usually one-dimensional. There are methods for multidimensional, but anyway. But the thing is that you're working at one part of your model. And so if you have a lot of arguments in your model, you need to go one by one. So that's super annoying. And still, that's useful because sometimes you, as I said, you can start with default priors, and then you have one or two priors that you want to pay attention. So for those cases, these tools are super useful. But anyway, sometimes you want to do something more automatic. So one idea is that, okay, why don't we make predictions from the prior predictive distribution, okay? And if you have predictions from the prior predictive distribution, then you can see what your model is trying to do. So that's super useful, right? So there is some functionality at this point in PreliZ to do that. For instance, you can pass a Bambi model or a PyMC model or a PreliZ model, because you can kind of define models using just PreliZ. And you can get samples from the prior predictive distribution, and you are going to get like box or sliders that you can tweak the values, and you can see the prior predictive distribution. So again, it's a simple idea, but it's try to make it easier, this iteration process that you have a model, you generate predictions, you do a plot, then you go back to the model, you make predictions, you do another plot. So it's trying to speed up that process, so making it a little bit more interactive. So that's something that is already there. It should work for many models. I'm not sure if probably not anything that you throw at it, but it's the idea that should work for anything. Probably it's not going to work for anything because, I don't know, you have to test it better, but the functionality is there. And then there are a couple of functions that try to be more automatic in the sense that you provide the model. So you have like, this is my default model with some default priors. And then in one of these functions, you'd also provide like a target distributions. That the target distribution is supposed to be the distribution that you think the prior predictive distribution should be. And this function is trying to make both as close as possible. And this is the most experimental method in PreliZ at the moment, because essentially that's kind of an inference problem, right? So, I mean, you are not trying to reinvent Bayesian statistics. You should do that in a way that is super cheap to do and super fast to do, that kind of thing. So there's some functionality for that. It works for models that are super simple, and it provides something that makes sense. And also it's kind of experimental that if you provide like the default, you provide a model with I don't know, it has a normal and a half normal. For instance, that two parameters, half normal and half normal. There is some experimental thing that is, maybe it returns a normal and a gamma, because say it's better to have a gamma as a prior and not half normal, because you're super shifted, something like that. So half normal is not a good fit. So that's something that is already there. Again, it's super experimental. I play it from time to time. Not sure if I will use it. I'm probably not sure if it will work for a very complex model, but it works. It at this point actually worked for some models that are not that simple, like hierarchical models, that kind of thing. It worked for that. And then the other method that is for prior elicitation that I think is not very good in practice, but I think could be good for teaching. Still not sure if it's something that it actually would or not. Something like that. It has to be decided yet. It's a method that you provide a model, it's going to generate samples from the prior predictive distribution, and you are going to see some of these samples, and you can click. It's a 3x3 grid, and you say, okay, these samples look like what I think the prior predictive distribution should look like. And when you select, it's going to add those samples together, so you have another kind of plot down that you can see what happens when you collect all those individual samples, and you can go clicking, and every time you click, it's trying to, in a sense, learn. It's super silly inside. It's not like I'm not using generative AI. That's not that kind of thing. No, not neural networks. Just comparing distributions. But essentially, the method learns that you like distribution that has some shape, some mean, some variance. So it's trying to provide you with more of those samples. And internally, it's also automatically adding samples that you didn't select manually, but are super close to the ones that you select. So we try to enrich the population. Anyway, it's the same thing. You are trying to approximate what you have in your mind as like a target distribution to what you are seeing as the prior predictive distribution. But in this, indeed, the other method was kind of automatic, and this method used your brain as the filter. I'm not sure it's super useful, but I think it's at least it's fun. It could be fun to show it to the students, and they can try to play and try to match distributions. So at least for teaching, that should be useful. And of course, because it generates distribution, you put a sense of is your samples are too off from what you have in mind, or are close, or are too narrow or too wide, that kind of thing that you get. But you also get to interact and play it a little bit with your distribution, and maybe waste a lot of time clicking with your mouse instead of doing actual work. But anyways. So, okay, that's PreliZ.
Yeah, damn. Thanks a lot, Osvaldo. That was quite a performance. Like a one-man show about PreliZ, ladies and gentlemen. You should drink some water. I'm surprised you don't have any mate with you. I can see that Tommy has, of course, his mate.
No, I usually only drink mate during mornings.
Okay.
Or maybe if I have to drive, I have to go to a...
Right.
I don't know. Yeah.
I see.
So
to anybody who hasn't tried mate, I definitely encourage doing that. Of course, it's better to do it for the first time, under supervision. So go to Argentina or Uruguay and then have a proper mate. Thanks a lot, Osvaldo. I think Tommy has another question for you, so I'll give him the floor. Just want to say that, of course, I put the link to the PreliZ package in the show notes. And definitely, again, encourage people to check it out, because I use it all the time in my modeling workflow. What I really love is that it marries very well with PyMC also, so you can have the prior elicitation and then just ask PreliZ to output that as a PyMC distribution directly in your PyMC model. So it makes the workflow way more transparent, also super reproducible. And as you heard Osvaldo say, there are so many things you can check out here. So very probably there is something you need. Go check that out, and also, ask Osvaldo if he needs any help on the repo.
Yes, I need help if you want to provide help. I'm super happy.
The answer is always yes.
Yes.
Question. I have a very short final question, which is something I'm curious about. So it is a question I thought I knew the answer to, but I realized my answer was extremely silly. So you said PreliZ is a sister project of ArviZ, and when you say PreliZ, to me the name makes total sense because it's prior elicitation. Okay, you glue both words and you get PreliZ. And what's the origin of ArviZ? What does it mean?
Is RV like in random variates? Yeah. When in a group you write, or if you are writing and you write random variate, and you write R, V, and S. So ArviZ.
Yeah.
And then
that's the reason.
yeah, that's the reason. And
Yeah.
then we say that with an S, and then we say, okay, we could use a C because it sounds like a visualization.
Yeah.
That's the original thing.
Okay, do you want to know what used to be my internal answer?
Okay, yes.
Of course.
So this is a visualization library, and it was created by a guy in Argentina who's very patriotic. So ArviZ, of course. No, it didn't make sense.
Very
yeah.
Argentinian,
Yeah.
very Argentinian hypothesis from you.
Yeah.
There was a time in Argentina that everything was art something. You remember?
Yeah. That's why I
Yes.
supposed
Yeah.
that could be the reason. But yeah,
Yeah, mainly from the
I was
visual,
wrong.
they were trying to
Yeah.
promote like it's everything package or whatever they do, it has to add something. No, I realized after doing that it could be the case because I think Colin make that assumption. I don't remember. I think it was Colin Carroll would say, okay, because you are Argentina or something like that. But no.
Good, thank you.
So yeah, Tommy, feel free. I don't know if you have other things, but feel free to stay here and ask other questions. Otherwise, if you need to go, of course you can. But thank you so much for dropping in and making that surprise appearance for Osvaldo. Actually, talking about ArviZ, I think you guys are working on ArviZ 1.0, Osvaldo, right?
Yes, that's
is
right.
it something you can share with the world? And
Nice, top secret.
I mean, that's the main, like, LBS is kind of like the CNN of the Bayesian world. So,
Yeah.
you know, it's like, you
No,
have
but
a large
this is
audience here.
classified information. No, actually, yes, we are completely rewriting ArviZ. Completely rewriting. Actually, is one of the things that we are splitting in three submodels. And again, probably when this gets released, users are not going to notice that unless they want to install them by separate. So you will be able to just call all the functionality from a single place. But from time to time, we get people that wants, for instance, to compute, I don't know, R hats, but they don't want to do any plot. So we are splitting, and for those people, there's going to be easier to install ArviZ without needing to install plotting libraries. That makes a lot of sense when you're, for instance, working with clusters, universities, typical scenarios that you work in a cluster. The guy in charge of the cluster say, okay, you only have to install only the things that you really need. Okay, so now we are going to split this functionality. Another thing we're working is that it's going to be much easier. We're still going to have like this batteries include plots that you just call something like PPC, plot PPC, and you get something and you don't need to do anything else. But it's going to be much easier that once you call the plot to tweak it. So we have a thing that has some reminiscence of grammar of graphics in a sense. It's not exactly that, but I think you, Thomas, with the first time you saw, because this is something that Oriol proposed. I think the first time you, Thomas, saw it, you say, okay, this looks very close to grammar of graphics. So there's some inspiration there. But yeah, so essentially you're going to be able to call a plot and then tweak it quite a lot. Even you are going to be allowed to do completely nonsensical things. Super easy. So probably unexpected things that are useful too. And for us, it's going to be much simpler to add new functionality. And actually, this past week, I was working on some functionality that is not available in current ArviZ. This is for checking prior sensitivity, likelihood sensitivity checks. Essentially, I add part of a few things to compute the statistics and whatever. When I was to create the plot, I started thinking, okay, I need to do all this work, and I start working like super complex thing, and then I realized, oh no, I just need to call the function that we already have and do some manipulation of data a little bit, and then call a function, and voila, I have a plot that has a lot of functionality, and I didn't have to write anything. So even I was surprised, Oriol was surprised, Andy that's also working and there was surprised. It was so easy to create something entirely new. And another thing that probably is going to be very useful for people is that if you want to do something much fancier, we provide like a new object, something that's called plot collection. That in a sense is like in this new ArviZ, everything is like an X-array data set or data tree or that kind of structure. So it's super. It's built around taking advantage of properties of X-array data structure. So this plot collection is going to allow you to, if you want, to build your own kind of plots. So I hope that will be useful also for researchers or people that want to like push boundaries, not reuse some plot, but create something new. I think that's going to be much easier to do it with this interface. So that's something that we are quite excited about that. And of course, we are adding new methods that are not available. As I say, this prior sensitivity checks and I don't know, other methods that are not available now in ArviZ. We are starting to move or add those methods in ArviZ 1.0 because we want to be ready as soon as possible. Actually, it's already usable. You can go and check. Probably we should add the others of the repository, and you will see that currently you already have like plot forest. Actually, I love the plot forest in R&D new ArviZ. It looks super amazing. It's super clean. I don't know. I just want to look. It's like looking at the of a drawing or a good picture. It just look nice. We have, I don't know, we already have a lot of functionality. Not everything is there, and some functionality is going to be in the new ArviZ and not the old one. But again, I think in a couple of months, once this episode gets published, it's going to be much more usable. One thing that is super nice is that we have internally a better way to handle with different backends. So currently in ArviZ we support Matplotlib and Bokeh, and in ArviZ 1.0 we also have Plotly. So we have Matplotlib, Bokeh, and Plotly. Again, it was a pleasant surprise when Oriol added Plotly because it was relatively easy work, and suddenly we have a completely new backend working almost perfectly out of the box. Still, there are some things that we need to polish, but it was surprising even for us that you can just add a couple of things and you get something that works. Actually, at this point, Plotly works better than Bokeh. It's super nice. So yeah.
Yeah, damn, that's super exciting. For sure, let's put that in the show notes. The link to ArviZ 1.0. That sounds amazing. Yeah, I mean, can't wait to see the forest plot now because I use forest plots all the time with ArviZ. It's just the best ones, especially when you have models with a lot of dimensions.
Yeah.
It's one of the best ones because you get a lot of information in just one plot. Something I always have difficulty with is mainly diagnosing and then visualizing models where you have one dimension or several which are huge, So for instance, like for my main job with the Marlins, for instance, my models, I have a ton of players in them, So it's like if you have a model with 10K players, it's a challenge to visualize a trace plot or even a forest plot. So yeah, this I'm still trying to find my go-tos, but plot forests definitely one of mine. Love it.
Yeah, definitely. I still fan of KDUs because I like how they usually encode information, but I'm becoming more and more enthusiastic about just point intervals, like in plot forest, just a point on some interval and that's it. Because as you say, when you have a lot of things, it's much easier to compare. I mean, you don't have to worry about things like the bandwidth that you're using. I don't know. There are many things that are useful. Of course, each tool has their use, but I think plot forest and in general the ideas of have point intervals is super useful.
Yeah, definitely. And also, so if at some point you find some good plots and illustrations for models with huge dimensions, please let me know. Something I wanna talk about with you too is intuitive Bayes, because you've done some work over there, mainly writing down some really good educational content. If you can briefly talk about that, and also we should definitely put that in the show notes.
Yeah, sure. Well, I think the first things I did for intuitive Bayes was practical MCMC. So essentially, it's a course for people that I mean, you don't want to get an expert into sampling methods. Actually, the promise of probabilistic programming language is that you don't need to worry about the sampling. You only need to worry about defining your models. But of course, in practice, it's usually a good idea to at least have a conceptual understanding of what MCMC methods are doing. Because if you have this conceptual understanding, it's easier to diagnose and know what things you can do to fix when you have problems like bad trace plot or divergences or that kind of thing. So essentially for practical MCMC, we do that, something that's very conceptual, and we try to use a lot of animations. And that was one of the things that I was more excited because I'm used to teach writing books or tutorials of things that are static. And then when I teach live, I try to have something that looks closer to an animation, but usually very simple ones, very rudimentary ones. So with practical MCMC, we were able to do something like this, looks a little bit more fancy, a little bit more entertaining. So we spent quite time trying to do that and making those animations actually something useful, so students can actually learn the concepts in a faster and easier way. And essentially that it's a course for people that want to do things in practice and they want to get some understanding of MCMC methods and how to deal with them in practice. And then we wrote workflow guide that also was something interesting because, as I say earlier, talking about the workflow in a practical way is sometimes not that easy. It's kind of challenging because of the nature of non-linear nature of a workflow, all these branches and different things that you can do in actual work. But anyway, we try to provide like it's a short guide. This is a PDF. The other one was videos. This is PDF, and it's a kind of short guide that provides like the general ideas of the workflow. So at one point we have like a kind of description of a linear workflow. We clarify, say, okay, usually things are not linear, but we're going to put one step below the other, and try to provide some of the things that you usually want to pay attention at each step. And then we provide an actual example when we go and iterate and we play with the prior predicted distribution and do some prior elicitation and then check the model and then decide if we want to go back or not and repeat something and that kind of thing. Actually, we find issues and we go back. I don't know. And this is like, as I say, it's a short guide and was kind of a proof of concept because we wanted to see if we were able to write like this short, relatively short, like booklets for people that they already know what they don't know, or they already know what they need to improve. So it's short because we assume you already know what Bayesian modeling is, you already know what samplers are, you already know your tools, but you need this extra step. Okay, how do I proceed in actual modeling? And we also have some work is not already published. We are working on that for prior elicitation. So we want to create also a booklet, and or we're still trying to decide video course lessons for prior elicitation. And again, prior elicitation in the context of the Bayesian workflow and probabilistic programming. The things. When do you want to do prior elicitation? How much time should you spend doing prior elicitation? What kind of priors? That kind of thing. We are well. It's not a surprise probably from the audience. I think that we really like weakly informative priors. So we try to center the discussion about, okay, but what are weakly informative priors? We try to provide a practical definition of that, so you can try to aim at working with weak informative priors. So yeah, I think it's quite. I have been super happy of working with Intuitive Bayes, as I say, because for all the projects we have trying to do something that is new in a sense. Not only that, because I already have some experience teaching Bayesian statistics to people. So when at each project we try to do something new in that sense, something new in how we are going to teach this concept that I have probably teach many times before. How to approach it in a different way, or how to try to collect all the things that you tried in the past and didn't work, or do it differently. So it has been super fun project.
Yeah, and I definitely recommend listeners to check those out, all of those. So I put already your practical MCMC course in the show notes. And please, if you can add, well, at least the first booklet, I know it's out, if you can add the link to the show notes. The second, as you were saying, I think you're still working on that, but maybe by the time this episode is out, well, we'll add it, and definitely I'll recommend people check that out, because as a lot of your work, I'm guessing it's going to be very to the point and enough technical details, but not too much. So that's definitely the kind of thing I like in your work and in your writing in particular, is like you give the readers enough technical details to make them understand, but at the same time you're not just drowning them in a sea of technical details that are not necessary, at least to start with these kind of methods and actually use them in the wild. So well done on that. I love that.
Thank you.
And on that note, by the way, and there is always a lot of humor in your writing, because you're quite a funny guy. I have to say to the listeners, in case they didn't notice. And actually, if people want to read more of you, you have your book, right? That was the first book I read when I started learning Bayesian statistics. Now you have your first book, that's the title is Introduction to Bayesian Statistics or something like that.
No, Bayesian analysis. No, Bayesian analysis with Python.
Yes, Bayesian analysis with Python, with PACT, and that's your third edition, right? I think you're already. Right. Damn, congratulations! I know how it's hard to write one book, so 3. I don't know. And thanks to you, actually, you managed to have your editor give some goodies to the listeners. So we're gonna have a handful of ebooks to distribute to the patrons of the show, where we're gonna do a random draw in the Learn Based Stats Slack, and then the winner are gonna hear, I'm guessing, from Pact. How many books are we able to give away this time?
I'm not sure, really.
Okay, so we'll get back to you on that, folks. And for the rest of you, you have a discount code that we'll also put in the show notes when that episode comes out, so that you can buy Osvaldo's book at a discount. And again, really recommend anything Osvaldo writes, because it's usually really well done. So thanks again, Osvaldo, for setting that up with Pact.
Okay, thank you.
So we're already at 1 hour, more than 1 hour, so I don't want to take too much of your time. So I'll ask you again the last 2 questions I ask every guest at the end of the show, because that's cool. You get another stand at that. But a personal curiosity I have, I talked to you about that a bit, but I thought it would be interesting to talk about that on the show. BART for time series. Is that possible? How is that possible? Is it just something that, you just add a BART prior to, I don't know, a model you're already doing, kind of a linear regression on which you have a temporal element like a Gaussian random walk? Can you also add a BART to that? How does that work? Is that possible?
Yeah, you can do that. There's actual probably 1 or 2 examples I see from Juan Orduz, because he has worked a lot with time series. I personally have not worked a lot with time series, so that's something that usually isn't out of my radar. But yeah, in principle, you can do it. As I say, probably one difference with Gaussian processes is that you work with Gaussian processes for time series or other method for time series, is that you kind of try to construct your time series by adding different terms that encode different kind of information at different levels. And in that sense, BART is a little bit more dumb. But it's something that they have been thinking about how to try to add a little bit more structure to BART models. And there's actually some literature about that, like, for instance, telling your BART model that one or more variables are always increasing or always decreasing or whatever. But I think there is something to work on, how to provide more information to encode more prior information into BART, and also how to combine more BART models. Like, maybe you can build different BART models together and try to build a more complex function in that way. I think there's something that is missing from the literature, and I think that's partially because this idea of having like BART models as standalone models. The moment you move from there and you say, okay, no, BART model BART is not a model. It's in a sense it's a stochastic process or a distribution, if you want. Then we'll start thinking about, okay, maybe I can do much more general stuff and much more complex stuff. So I don't know. I'm hoping people. Actually, my hope is that people using PyMC-BART try to do that for me. So I have not to do it, but they were able to do it with PyMC-BART, and they show me how to do it, and so I can learn from them. That's my ultimate hope with PyMC-BART.
Yeah, I can get that. Okay, so that's interesting. Basically, you're saying that, yeah, BART are more black boxy in a way. So it's kind of like you use a BART or you don't, but it's not something that's modular in that you can use a component of your linear regression, for instance, could be a BART, and in addition to that, you have what you were saying for Gaussian processes, for instance, where you can model a trend, you can model the seasonality, you can model short-term variations, and each of these three components you could do it with a Gaussian process, or you can also have structural time series, as we'll talk about with J.C. Grabowski, where you model your trend, you model the seasonality, each with two different well, not models, but let's say methods in the same model. And also you can use something like an ARIMA to then model the rest, the residuals, once you've taken the trend and seasonality into account. What you're saying is that you cannot really do that with BART.
What I'm saying is that it's more difficult to give priors to BART, in the sense the priors are super general, in the sense that you pick the number of trees and then you say you have some probability of how deep the trees can be. But it's not that easy to encode a lot of information into the priors. Like, for instance, you can do with kernels and Gaussian processes. Okay, that's the things that I'm saying. But I think it's not something that is intrinsic from BART. It's more of the methods that are viable. And probably I'm saying this, and maybe I hope some listeners say, no, but I know about the model when you have blah, blah, blah. Because there are a lot of things. For instance, there are BART models that at each leaf node, they return the Gaussian process. Okay. So the answer of the result for models is, sum of Gaussian processes. So that's super complex, and you can do a lot of things with that. What I'm saying is that at this point with PyMC-BART is much more flexible than other methods, in the sense that you can use as part of a model. For instance, I know Chris Fonnesbeck from PyMC, he has used models that include BART and GP components in a single thing. So you can do that. What I'm saying is that we need a little bit more work in able to provide like more prior information, or encode more prior information directly into BART, so we can restrict. The thing is that BART models are super flexible. When you have something that is super flexible, it's always a good idea to say, okay, I want to restrict you to be more of this type or this type, because that's a way to encode prior information.
Right. Okay. Yeah. Get that. Yeah. Super fun. I mean, I can't wait to play with all these different methods we just talked about throughout the episode. I'm already playing with a lot of them, but always learning. So that's really cool.
Yeah.
And
never ending.
Yeah. It's part of the job, right? Sometimes it's a bit like, oh my God, I don't know anything, and most of the time it's like, oh, okay, now I understand that thing, but now I have to go learn that next step of that method, or learn that new method to actually combine it with another one I know about. So yeah, that's really the challenge, and also the joy of that line of work, let's say. So I put the blog post from Juan Orduz that you talked about. I think it's the one looking at a cohort retention analysis with BART. It sounds like it's a time series with BART, so I'll definitely give it a read, because that's like that sounds super interesting. And since you mentioned GPs, I also put in the show notes two newish, now they have a few weeks, tutorials that Bill Engels and myself wrote about HSGPs. So Hilbert Spade's decomposition of the Gaussian processes, which I definitely recommend people interested in GPs to look at, because honestly, HSGPs, if you're doing 1 or 2 dimensions, sometimes 3, but at least 1 and 2 dimensions, it's absolutely amazing, and that changes a lot of things because it's way faster to compute, way more efficient. And so if you want to get started with HSGPs, I recommend these 2 tutorials. First one is that guides you through the basics, and the second one is demonstrating 2 more advanced use cases.
Yes, I have to teach GPs in a couple of weeks. I'm going to steal all your material from my class. So,
Perfect. Awesome. Yeah, can't wait. I love these methods. So really love hearing that they get propagated even more in Argentina. Which is dear to my heart, as you know. So I think it's time to let you go, Osvaldo. It's been a while. You need to get some alfajor in your blood. But
Next time.
before letting you go, I'm going to ask you again the last two questions I ask every guest at the end of the show. So first one, if you had unlimited time and resources, which problem would you try to solve?
Yeah, I think I'm going to say exactly the same. I mean, I'm still motivated to work on Bayesian methods, and I say at the beginning, for me, it's really something. I'm super happy when I get some code and you get something like a plot forest or something like that, or the first time you see PyMC-BART running and it's actually fitting something that at least looks reasonable, or talking with other people like Gabriel and he say, okay, I speed up this 10 times, or whatever, or with Thomas about Bambi. So yeah, I think I'm still super interested in working on Bayesian methods and making Bayesian methods more useful to people. I think it's even more interesting to me to make methods so other people can do stuff than doing the stuff. Like this kind of general approach. So yeah, I will keep doing the same. And if I have more resources, I will have more time, more people to help with this. So
that sounds good. I love it. And who would be your guest if you could have dinner with any great scientific mind, dead, alive, or fictional?
I don't know. That's all. It will be easier if we all participants of your podcast have a single banquet with all the people, so we can switch tables and talk to many people. So we should try to organize something like that at some point. I don't know. It's super difficult to think about a single person. The last time I think I mentioned Harold Schlager, that I have the opportunity to have language with him. He was from my previous life as a bioinformatician, biophysicist, or whatever. For statistics, I don't know. I don't know if I have some like statistical hero yet.
I see. Yeah.
I have some people that I already have the opportunity to have lunch on I don't know, but they're too close to mention, so I don't want to sound like a.
I think so to get back to Argentina, I think Jose Luis Borges would be an interesting person to have dinner with.
I don't know. It's super intimidating.
So not technically a scientist, but could be interesting.
No, but it could be super intimidating. It's a guy that it's a guy that is like, whoa. I don't know if listeners have read him, but even when that we're reading fiction, he always kind of transmit you this idea that he's saying something that is super profound, true, something like that. I it's just bullshit. It was fiction, but I don't know. It has very, very interesting style of writing.
Yeah, definitely. But I mean the Garden of Fucking Path, things like that. I think it's definitely scientific-ish, let's say, so it'd be interesting to talk about him, how he came up with these ideas.
No, we have many things that looks like scientific in a sense. They're fiction, but it looks like kind of could be science fiction easily.
Yeah, definitely. Yeah. Awesome, Osvaldo. That was a pleasure. Thank you again for taking the time. It's always a great pleasure to have you on the show. Of course, the show notes of these episodes are going to be huge because you do so many things. But so I've already added a lot of things. Feel free to add other links that we mentioned today. And of course, links where people can follow you. And maybe before we close up the show, can you tell people where they can follow you, where they can support your work, something like that?
Yeah, I am still on Twitter. I'm still calling Twitter, but probably I'm going to migrate. I'm also on Mastodon. And it's all the same. It's Alaptarovia. It's the same handler for everything. I'm in Blue Sky. And maybe we can then share my personal webpage. That is essentially a place that you can go and see what I'm doing at the moment and what I'm in LinkedIn. I have to admit that I hate LinkedIn, but I'm there for some reason. I still don't understand what people are doing there, but I see that a lot of people posting interesting things, so I started to follow those folks.
Perfect. Well, I'm sure people will connect there. Thank you again, Osvaldo, for taking the time and being on this show for a third time.
Thank you. I only need 7 more.
This has been another episode of Learning Bayesian Statistics. Be sure to rate, review, and follow the show on your favorite podcatcher, and visit learnbayesstats.com for more resources about today's topics, as well as access to more episodes to help you reach true Bayesian state of mind. That's learnbayesstats.com. Our theme music is Good Bayesian by Baba Brinkman, feat. MC Lars and Megaran. Check out his awesome work at bababrinkman.com. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country. You can support the show and unlock exclusive benefits by visiting patreon.com/learnbayesstats. Thank you so much for listening and for your support. You're truly a
good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations. Let me show you how to be a good Bayesian. Change calculations after taking fresh data in. Those predictions that your brain is making, let's get them on a solid foundation.